I don't know the size of Earth, and I don't want to assume it. So instead, a group of us on TikTok ran our own version of the Eratosthenes experiment and collected 10 real measurements of the sun's angle at different latitudes, as seen here. If Earth is a globe, those measurements should follow a predictable pattern. And if they don't, the whole thing falls apart. Globe debunked. We all used vertical sticks and measured the shadow to get the angle to the sun. This is what 9 of us used. And the 10th person, to test what will happen if we use our own household objects, used this pole. Every measurement got us 2 bits of information: the latitude north and the angle to the sun. This here is our measurement sheet. The one in red is the person that did not use the same apparatus as the other 9 measurements. This data is publicly available for anyone to use. The link to this will be in the description. But as you can see, as latitude increases, angle decreases. This is measurable and predictable. There is one discrepancy that stands out immediately. This person here, they're at 34 degrees north, they measured 15 degrees. We know, just looking at the data sheet here, that that's not accurate. My guess is it's probably 55. You could look at the picture they submitted and try to make sense of what it is. Fun fact, 2 flat earthers said they would participate in this, and I mailed this apparatus to them, and one of them actually did. The other one, I think, conveniently forgot that this was happening. There is a small caveat. When I designed this apparatus, I used angles down here instead of measurements, and this pole, I went off of the center line of the pole. The center doesn't cause the shadow, the edge of the pole does. So, from my calculations, everything was somewhere between 1/4 and 1/2 degree off. I took kind of a rough average and did 0.3 degrees. So every measurement, except for this one, I've adjusted by 0.3 degrees. Disregard this because this was for a different video. So here's the data that I did. Here's what I broke down. This first example here is to show what happens when we use incorrect data. This number 5 at 15 degrees. So first we needed a distance measurement. What I did was looked through the US, since that's where most of my audience is, and I found this highway here that is really straight north-south in Kansas. And I measured this distance. This is a road that anyone could drive and verify. I live nowhere near Kansas, so I can't do it. But anyone could drive this thing and verify that this is a 1 degree difference on Earth. And when I dropped these pins right on these lines, I got a measurement of 68.95 miles or 110.96 kilometers. So we're gonna use this. We'll just assume I drove this distance that was 1 degree, 36 to 37 degrees north, got 68.95 miles. And this is Eratosthenes' formula. So the circumference of Earth equals the distance between the 2 points, which we calculate over here, divided by theta, which is the difference in the sun's angle, right there, times 360 degrees, because we know that is how many degrees are in a circle or a section of a ball. So to get this, we did the difference in latitudes between 10 and 5, the difference in angle between 10 and 5. This cell was 765 miles, just multiplies the difference in latitude by the miles we measured. And I have kilometers in here for everybody that's not US based. So then what we did is basically Eratosthenes' formula. We measured 1 degree is 68.95 miles. We took our distance, divided it by the angle difference to get essentially one section, and then multiplied it by 360 because we know that's how big a ball is. And with incorrect data, we got the globe circumference is negative 9,033 miles. I don't think we have a negative circumference, so that's why we're disregarding this data. And I apologize to number 6, because you probably had accurate data, but we aren't going to use it because we needed a sacrificial lamb. The greater the distance, the better this measurement becomes. So I'm using 1 and 10 first. This is measurement 1, measurement 10. They're the farthest apart. We got the difference in angle, and essentially a quick double check is when these two are close to matching, we know that it's a close measurement. You can see up here, these two are extremely far from matching. So then we do the same thing. We're using the same miles we measured. We got the distance. We got 24,941.1 miles of circumference. But what I did was did this with 1 and 10, 1 and 7, so 1 gets used again because we want the biggest gaps possible, but I wanted to use a bunch of the data. 2 and 8, 3 and 9, and then 4 and 10. So 10 gets used again. Thank you to the person at 45.1. I won't divulge names here and give away locations. but your far north measurement was helpful. We did all the math for it all, and we got these measurements across the board here. So what I did was took the average of these 5 measurements. We got 40,783 kilometers and 25,342 miles. So these numbers here are what science and reality and world travel tell us, that the circumference of the globe around the poles is 24,860 miles. The circumference around the equator is 24,901, so it's a 41-mile difference, which is not massive when you're talking 24,000 miles, but this is what science tells us. So when we use our average across these 5 calculated measurements, we only have a difference of 1.94%. And that's probably bigger than it should be because of some massive outliers. Like this measurement between 2 and 8 was off by 17%. And then the one between 3 and 9 was off by 6.81%. But we're using averages because science is fun and averages are what matters. So 1.94%, which in reality means that the 9 of us measured Earth's circumference, we were only off by 480 miles. What I think is even cooler than that is if we just take the one measurement, like Eratosthenes did with just one measurement in Cyrene and Alexandria, we're only off by 0.33%. or 81 miles. In my opinion, that's awesome, but you don't have to agree. So what happened? We didn't assume the size of Earth. We measured the sun's angle using shadows. We measured miles per degree ourselves with real north-south route on a highway. Then we used those measurements to scale up the full circumference of Earth. And as long as measurements are done correctly or relatively close to correctly, the data behaves the way a globe predicts, and we got, on average, 480 miles from reality with 9 humans using a $10 piece of equipment. And our best one here, thank you 32.5 North and 41.5 North, you guys, just the 2 of you together, were within 81 miles of Earth's actual circumference. Now, if you want to participate in science like this, you can. We're going to redo this in September. During the September equinox, which is September 22nd, we are not going to take our measurements on exactly September 22nd because that is a Tuesday and a lot of people have day jobs. But this is the form to fill out to participate if you'd like to. That'd be awesome if we could get 30 people. This one's going to be bigger, better, badasser. We're going to do globally, so anyone in the entire world can participate. And you don't need a 3D printer. You can use whatever you have laying around your house. Just please use an accurate tape measurer. So the information, we want the TikTok username. If you are not on TikTok, if you see this on YouTube or Reddit or somewhere else and you want to participate, you can still participate. Just put NA for TikTok so that I know that you aren't on TikTok and I can't find you there. Contact, email, or TikTok message. If you're on TikTok, just put TikTok. If you are not on TikTok, you can put your email. If you don't want to, you don't have to. This is just for me to contact you if I have questions, comments, concerns, you're having issues with anything, kind of so that we can communicate if need be. Do you have a 3D printer? This is, like I said, you don't need a 3D printer, but this one is so that I know who I need to make sure the file gets to. But if you don't have one and you've just got a straight stick that you can plug into the ground plumb, we're good. What city, state, and country do you live in? This is strictly for me. No one else will ever see this data except for me. And the only reason I'm asking for it is for instances like this where I'm drawing the lines and seeing, are there any gaps that we need to fill in, or where people kind of are, where people are going to take their measurements from. Should we do it Saturday, Sunday, or Sunday, Monday? This is because the equinox is on the 22nd, Tuesday. Most people work. So I'm asking, would everybody like to do it on Saturday and Sunday, or Sunday and Monday? I want to keep it to 2 days just to limit the variable of the sun's slight position change. It is very minuscule over 2 or 3 days, but I'd rather eliminate as much variables as possible. We will go off of whatever 2 days people choose. So the most popular vote will get it. I said Saturday, Sunday, Sunday, Monday, because some people do work a weekend day and then end up having like Monday off or something. And then what shape do you think Earth is? This is kind of a redundant question, but this is just so I kind of know who's participating. Flat earthers, globe earthers, hot dog earthers, we live in the matrix and nothing is real earthers. But the link to this form will be in the description and the comments most likely. Then, as stated earlier, the measurements were slightly off by like 1/4 to 1/2 a degree, so I'm redesigning this apparatus. Again, this thing costs like $8 to $10 to print, so it's not horrible. These lines are spaced by 5mm gaps, and they're 1mm thick, so we're gonna have an extremely accurate measurement here. So the base here, the design is you screw these poles on, and we made it about 40 inches tall the first time, but like I said, it was measuring from the center of the pole and not the edge. So what I'm doing is redesigning the top of that pole, but also making it so that you can shove a 1/2-inch dowel rod in here, so you could just print this instead of the tower of poles. Shove a 1/2-inch dowel rod and then measure the shadow, and we just make sure measure the height of the dowel rod and the length of the shadow, and we're good. And these millimeter distances go off of the edge of this. So right where the edge of the dowel rod, or I'm going to redesign the top of the pole, the edge of the pole will be. But this is the redesign coming, so don't download the one that exists on Maker World right now, because it will be changed. And again, I think it's awesome that 1 in 10, you guys killed it with an accurate measurement of within 81 miles of Earth's real circumference. On average, all of us measured within a 2% accuracy and only 480 mile difference. Again, with humans, error, and a $10 piece of equipment. Thanks for watching. If you liked it, leave a like. If you didn't, too bad. No, leave a dislike if you didn't like it. And then if you have any questions, comments, concerns, leave them in the comments. If you have anything else, any cool science you want done or want me to look at, let me know. And we'll see you in the next one.